Okay, let me demonstrate the brute force method for finding the fastest route through a network. And we're going to be using a complete graph with 4 vertices. Each of these little circles represents a vertex, and in this context it will represent a town. Those are the towns, A, B, C, and D. Complete graph, there's a direct edge between every pair of towns. In other words, there is a road that you could travel to go directly from each of these towns to another town. And I'll fill those all in. What I'll do is I will use an alternate picture around the outside here. Now, similar to the way it's done on the examples in the workbook, I will put in parentheses the number of minutes that it takes for the salesman to drive between these towns along each of these roads. Based on the various conditions. And the question that we're trying to answer here is, what is the shortest number of minutes it will take for the salesman to make the trip starting and ending at his home A to each other city and then returning home? There are 3 possible routes that the salesman could travel. Could go from A to B to C to D and back to A. Now the total time for that route would be from A to B is 12 minutes. From B to C is 10 minutes. From C to D is 5 minutes. And then from D to A is 4 minutes, for a total of 31 minutes should the salesman choose that route. A second possible route the salesman could travel would be to go to A first, then go to C, then to B, skip around to D, and then go back to A. Now, with that route, the length of time would take, let's see, 6 minutes to get from A to C, then 10 minutes to go up from C to B, 15 minutes around the horn there from B to D, and then 4 quick minutes back to home. 16, looks like 31, a total of 35 minutes to make that trip. The last possible option would be to go from A down to D, and then let's go from A to B, and then over to D, and then to C, and then to A. So A to B to D to C to A. Now that one would take, A to B is 12. Then from B to D, looks like 15 more. From D to C is 5. And then from C back to A would be 6, for a total of, looks like 27, 37, 38 minutes. Right, now there are 3 other possible routes that I could take, but it turns out that each of the other 3 routes would be these that I've given you in reverse. In other words, instead of going from A to B to C to D to A, I could go from A to D to C and then B and then back to A. But if you were to think about it a little bit, the amount of time that's going to take you to do that root, which is this one in reverse, is exact. And so there are a total of 6 roots. Now the brute force method says you must check every possible root. And of those possible roots, the one that takes the least amount of time would be the solution to the problem. And in this case, we see that the very first one we chose, the root from A to B, and from B to C, from C to D, and then back to A, is the shortest route. That's the brute force method. Check every possible route. The one that is the shortest is the solution to your problem.